Hello everyone, how is everyone today? I hope you had a good day. It was beautiful sunny out there today in Toronto. Uh, Great. So let's start with another lecture on computer programming lecture series. Today we're going to be discussing about abstraction mechanisms, what C++ offers. C++ offers classes. It's a beautiful way of abstracting. In simple terms, a class is a type provided to represent a concept. Good. Now, what do we mean by concept? Say, for example, you drive car. Good. But car is a kind of a vehicle, right? So vehicle becomes a class. Also, car becomes a class. Okay. For another example, let's say a human being. A human being can it's a concept, right? We can represent it as a concept. Human being. It can be male. It can be female. Parent class is a human. Now all the properties of human will go to the male and the specific properties of male and then female. And then it becomes a type like type that language offers, say integer, it's a type. When you type 1, 2, 3, it becomes like a object of that type, same way. So the class offers the way to abstract the concepts. We have two kinds of classes or two kinds of concepts: abstract classes and concrete classes. Concrete classes, they behave just like built-in types, and their representation is part of definition. For example, you can create different objects of the concrete class, and how the objects are going to allocate resources in the memory, those are also defined as a part of class definition. Now, on the other hand, the abstract class completely insulates user from the implementation. So say for example, you don't know what this concept gonna look like, say for example, human being. You can say it's an abstract class, but then when you define male and female, it can become a concrete class. Now let's see how we can implement in the code. So in concrete class is simple. It's like a regular standard way of defining class. It has private members, public members, constructors, destructors. It's a part of the class definition. How to constructor, how to acquire the resources, and destructor, how to deallocate the resources when the object is out of scope. On the other hand, abstract class. See here the difference? It uses the virtual functions. The virtual functions offers you the flexibility to define its implementation somewhere else or in some other classes in the hierarchy. Major difference. See, in the abstract class, only all the virtual functions. Concrete class, you don't see here. There is no private element in abstract class. There is private element in concrete class. So this is just to give you an overview. Let's talk about class hierarchies. The class hierarchy, formally you can say that is a set of class ordered in a lattice created by derivation. We use class hierarchy to represent concepts that have hierarchical representations. What do we mean by that? Say, for example, different kind of things share common property. So that common property can be made as a parent class. So if we write a function for that common property, we just write it once and use it multiple times in different objects which share the common property. For example, here we want to draw a smiley face. So let's split. What do we mean by smiley face? So smiley face has a circle. Good. So circle. So smiley face inherits the properties from the circle. Good. So circle can become a class, parent class of a smiley face. And then circle, if we go a level up, what does it mean by circle? Circle is a kind of a shape. Good. So we make one more class, shape, and we associate the relationship as a parent-child relationship between circle and shape. But the shape, let's say shape, a circle is a kind of shape, but there are different other things which can be a kind of shape. Let's say triangle is a kind of shape. So the shape becomes a parent of circle and triangle. So circle and triangle share the common properties, common functions, common elements of class shape. Isn't it beautiful mechanism to split the resources into common and private, or common and specific, I shouldn't say private, but common and specific to that particular object. So we don't have to define it again and again. Let's say another example. Say you drive car. So car is a kind of vehicle. Good. But there are other kinds of things which can fall into the category of vehicle. For example, truck. There is a relationship, like say car will inherit the common properties of vehicle. In the same way, truck will inherit common properties of vehicle. Plus truck will have its own attributes. Good. Now let's see how we can implement the classes. So here, if we go back, shape, good, this example of a smiley face. So shape can become an abstract class, good. So shape becomes an abstract class. We write the virtual functions, different functions which are common to, common to different kind of shapes, let's say circle, triangle, and make it a abstract class. Now here, if we define the class circle, so class circle inherits the properties from the shape. So we can define this way, and it has the public elements and the private elements. Good. And this is a regular way. So circle becomes a concrete class here. Now we go further, smiley face. So smiley face here inherits the properties from the circle. Good. And plus the smiley face has its own private capabilities or private elements. So this is way how we can define classes in a hierarchical relationship using the abstract and concrete concepts. Good. Now see the difference here. Virtual, void, draw. So here the draw is a virtual function, means that its implementation is not defined in the shape class. Its implementation is somewhere else. So we define the draw, we draw a circle, so we define the draw function which applies to the circle. Good. Now in case of a smiley face, we again define a draw function which is specific to a smiley face. So see how we have defined class hierarchies using abstract and concrete classes. This lecture is just to give you an overview. If you have more questions and if you have more confusion about how to implement different classes under class hierarchies, parent-child relationship, or abstract and concrete class, feel free to send me an email or comment on the lecture. I will get back to you. Another kind of way C++ offers a template. A template, what is a template basically? Let's say a template is a class or a function that we want to parameterize with a set of values. So in case of class, we can say class templates. In case of functions, we can say function templates. And also a template can be defined to accept arbitrary number of arguments. So in simple words, template is a container. It's a big container or a big class. So usually a class, say for example, vehicle type. Good. So you have one kind of class that's say vehicle, okay, and then car and truck. So let's say car, you have car, but imagine a situation that that your class, all the definitions are same, and it's a big container you want to put in a big container. You want to put car, you want to put truck, you want to put all other items, and then you want to write some operations onto that. So how we can do that? We can define a class template, or it acts as a big container. What kind of type name? It will take what kind of object this is taking, or what is the type, and then the regular definition, class vector. Now here, see the difference, T asterisk element means the type T which you have defined here. Template, type name, type T. So if you define here say car, it will create the element, a pointer to an array of type car. But when you want to use this class vector as a truck, then this element will point to an array of trucks. So you don't have to define multiple times. You just define the class at one time, and when you want to use this class, you just supply the type name that I want to use as a car and I want to use as a truck. It will take it accordingly. It's a beautiful mechanism, templates. Now the same way you can use the function templates. So template here is the keyword, and template can have multiple arguments. Here we have just one type argument, type name T, but it can have multiple type names, say type name T, type name tail1, and blah blah blah. Good. So far so good. And then regular definitions, constructor, destructor, and some other operations. So important concept: class, concrete class, abstract class, templates. Good. I hope you have enjoyed this very short lecture to give you an overview about classes, abstract classes, concrete classes, class hierarchies, and templates. Do not forget to subscribe LibProfessor YouTube channel. If you need private tuitions or if you need help, you may contact me at hr@libprofessor.org. Hope you have a wonderful day, and thank you for subscribing and enjoying my lectures. Have a good day. Bye.